Hello students, now we will see how to derive the shape function or interpolation function for the steady state heat conduction in one direction again. So one dimensional element we can represent with this figure. You can see this figure E, where we have the wall. One end of the wall is at temperature T0 and then other end. Now if I am going to take single element out of it, I can say that it will be like this with the length L, x is equal to 0 and x is equal to L, both the ends of that element. Then at this end T0 is equal to T1, and at second node, at first node T0 is equal to T1, and at second node TL is equal to T2. Now to derive the shape function, we will take the polynomial first. So we will assume the polynomial function. Now consider this polynomial t is equal to a1 plus a2x. Then by applying the boundary conditions, we can able to get the values of a1 and a2, and again by back substituting these values in this equation, we can able to get the shape functions n1 and n2. So this is the procedure. First we need to find out the unknown values of a1 and a2, and then you have to back substitute it in the equation polynomial. You will get the n1 and n2. So this is the polynomial. We will have boundary conditions at node 1, x is equal to 0, t is equal to t1. So we will have t1 is equal to a1. This is equation 1, this is equation 2. Now second boundary condition at node 2, x is equal to L, t is equal to t2. So we will have t2 is equal to a1. Since a1 is equal to t1, we will again replace this a1 by t1, and then a2L. So again we will have t2, a1 is replaced by t1, and then therefore t2 is equal to t1 plus a2L. So a2 is equal to t2 minus t1 upon L. So we now have the values of a1 as a t1 and a2 as a t2 minus t1 upon L. We will back substitute these values in the equation of t, polynomial function, and then we will have t is equal to, this is a1 and this is a2, t1 plus t2 minus t1 upon L into x. So t is equal to, by simplification, we will have x is multiplied inside the bracket, and then it is t1 plus t2x upon L minus t1x upon L. Again t is equal to t1 terms we are going to take together, minus t1x upon L and plus t2x upon L. So if you take the t1 as a common, we will have 1 minus x upon L, bracket completed, t1 plus x upon L inside the bracket t2. So this is nothing but n1 and n2. So now we will have n1 as a 1 minus x upon L and n2 as a x upon L. So we can represent this in the form of figures as shown below. So we can have at x is equal to 0, we will have the n1, which is equal to 1, sorry, there is a mistake, actually it is n1 is equal to 1 minus x upon L, and here n2 is equal to x upon L, and then combined together we can have the t is equal to n1 t1 plus n2 t2, which is represented by this figure E. So this is all about shape function of one dimensional heat conduction problem.